Hamilton is a very exciting city, as we all know, and it's particularly exciting to look at photos from Hamilton that are historical pictures of Hamilton. And we got a neural network to look at those pictures and try to automatically date those pictures for us. So this is a very applied deep learning project that I'm talking about here, where we basically got an existing deep learning architecture. We got some data from the Hamilton City Libraries, and we got some photos from them where they annotated the photos with the decade in which the photo was taken, or the year, more precisely, if that was available. So this is work that was done by a master student of mine, Dong Wang. So I didn't actually do any of the work. All right, so here are a few images of Hamilton, historical images of Hamilton. There are a lot of roads in Hamilton, and interestingly, even the library finds it worthwhile to collect these pictures of roads, amongst other things. The data is quite varied, so we have quite a bit of data where we only know the decade in which the photo was taken, and then we have some data in which we know the year. As you can see there in these statistics shown there, we had about 2,000 images for training. 600 of those had just a decade as a label, and 1,400 were annotated by year. There's also a nice little histogram showing you the distribution. As you can see, and as you would expect, there aren't that many photos from early in the last century. So training a model that accurately classifies photos from that time period is probably quite difficult, and we'll see that in the results. The idea with the project was to actually train up a model and then make that model available to the librarians who currently manually date photos, and maybe give them some help, automatic help in getting this done more efficiently. So what did we try? We did try an existing convolutional network architecture. We tried efficient at B0, which is the smallest of the efficient net models, which are known to work quite well, and they turned out to work quite well in our problem as well. We did, in contrast to just using multi-class classification, we also tried to take the ordering information in the targets into account. The date ranges obviously are ordered, yeah, so we can have this as an ordinal regression problem or ordinal classification problem. So we tried a few approaches that train the neural network or a collection of neural networks by taking the order of the values into account. The decades, we used binary decomposition. We used an approach that's commonly used for logistic regression in the case of ordinal problems. Cumulative link modeling, it's a proportional odds model. And then we also used a loss function that is related to the squared error, but defined for discrete targets, known as the quadratic weighted kappa. And you can have there's a continuous version of that, and then you can optimize that as part of the neural network as well. And we also obviously tried regression, plain old mean squared error, deep learning regression. For the cases where we didn't have an exact year, we just used the midpoint of the decade. So those are the approaches that we tried, and I particularly was interested in ordinal classification. That's an old hobby horse of mine. And in fact, the ordinal binary decomposition method that we tried, we published that about 20 years ago at the European Conference on Machine Learning. And it was interesting to see how that would compare to the cumulative link model, which was published quite recently in the neural networks literature. So here are some results. This is the mean absolute error predicting the year. What I didn't mention on the first slide was for the test data, we actually made sure that we had the exact year. So we could make sure that we actually measure against the exact year of the photo in which the photo was taken. So here we look at the mean absolute error for the different predictions, again, for the different decades as well. You can see, as expected, for the initial decade before 1899, the mean absolute error is quite high. The best model in that case is actually the cumulative link model. For the other decades, however, with the best models, we are only about 10 years out, so maybe this is actually something that's usable in practice. We aren't at the point yet where we actually have established that this is useful to the librarians working in the Hamilton City libraries. We also don't know how well humans actually do on this problem. I mean, it would be nice to have multiple humans give the date for images and measure the agreement of the humans. We haven't established that either. You might wonder how we, so for classification and ordinal classification models, you might wonder how we came up with numeric estimates, because we only have probabilities for the different decades in that case. We used an interpolation method, a simple interpolation method, and the formula is given there to turn the probability estimates for the different decades into a numeric target. Okay, so this is mean absolute error. You can also look at classification accuracy if you look at just getting the decade right rather than the exact year. It turns out that ordinal classification actually helps there as well. So it's better to use the order information in the targets rather than just treating it as a plain classification problem. The simple binary decomposition method actually worked best in terms of classification accuracy. You can also look at the quadratic weighted kappa, which is this quadratic loss function that also gives you a nice idea of which method performs best. Sorry, I'm taking a little bit too long, but I want to show this. This is quite interesting because you can look at the predictions that are made and which cases are poorly predicted and which ones are well predicted. In the bottom row, we have the worst case prediction where the actual image was taken early in the last century, and the prediction was from 1968. And as you can see, probably the neural network mainly looked at the type of house or architecture that is present rather than the other features like whether there's a car or a horse carriage. And then in the top row, this was perfectly predicted. The year was exactly right. So this was an example of where it actually works really well. All right, so we have more work to do. In particular, we want to investigate whether we can build models, joint models for discrete and continuous targets, which seems to be something that hasn't been investigated very much. Thank you very much.